Bem, então vamos lá. A gente tem o prazer, então, de ter o Matteo Rini, para quem não leu o cartaz, né? Ele tem uma carreira científica, um doutorado em engenharia, também em física, era pesquisador ativo, e aos poucos foi migrando para essa área de comunicação da ciência e divulgação, né? Trabalhando na Comissão Europeia, essa parte, e hoje é um membro, acho que desde 2012, é um membro da APS, né, da Sociedade de Física, e é editor da revista Física. Quem não conhece, é uma revista de divulgação da APS, que coloca no highlight os melhores artigos das revistas de Coloquio, né, dá uma discussão mais de divulgação, né? Acho que é bem interessante todo mundo, mais estudantes, né? Assinar lá, tem um newsletter, você recebe toda semana, os maiores destaques da vida divulgada pela APS. Então, ele é editor dessa revista. E, bem, queria agradecer ao Matteo, que está escutando, né? Que se disponibilizou prontamente para discutir para a gente. E você também, Matteo, fica à vontade, se você quer falar inglês e português, eu acho que é uma coisa que você fica à vontade, tá bom para a gente.
Eu não entendi as últimas palavras.
O que eu queria que você ficar à vontade para fazer a apresentação em português ou inglês.
Sim. Não entendi isso.
Eu estou dizendo que fica à vontade para fazer a apresentação em português.
Ok.
Ou em inglês.
Sei lá, eu acho que em inglês poderia ser mais interessante, menos lento, mais fluente. Você o que acha?
Pode ser, perfeito.
Okay. Bom. Então, vamos fazer em inglês. Posso começar? Eu não entendi muito bem.
Pode, só que a gente não está vendo a sua apresentação, eles estão vendo sua tela.
Agora?
Agora sim, perfeito.
Ok. Se você tiver que perguntar algo, pode me interromper e falar, porque não vou ver a chat, por exemplo, do Google Meet, né? Então, você fala e me interrompe.
Tá.
Perfeito. Então, vamos começar. Bem-vindos todos, é uma grande honra estar aqui. Bom, vou falar inglês, então. Essentially because I have so many examples in English, and I don't know that I can translate them very efficiently. Let me know if you have any questions that you don't understand. So I didn't really get my presentations, but my how you present to be, but in a few words. I used to be a scientist, a laser physicist. I was working in Berkeley and some other institutions. And I was doing research for many years, for over 10 years. My career was planned to become a tenure-track professor and so on and so forth. But at some point in my career, I decided to work on an aspect that I think it's super important, an aspect that I like very much, an aspect that I don't think is taught in many universities, in many curricula. And so I'll tell you a bit more in my slides of how I got there. But essentially, the message that I want to give through this talk is the fact that scientists should think more about issues related to communication, writing, and presentations, and should feel that they should take charge of it. No one is going to do it for you. Some people may help, but you cannot hope to just continue doing your science and somehow some editors or some other people will take care of the dissemination aspects of your science. You have to be the person driving it. And there is no substitute, because you're the only one who knows your research very well, and the only one who has the instruments to find the best way to communicate it. So I both serve as the editor for Physics Magazine. It's basically a popular physics magazine where we try to communicate the best results in physics in a very accessible way. Our target audience is every physicist in the world, independent on their level, independent on their seniority, independent on their field. And I also, since the pandemic, since 2020, I became professor of science writing and communications at NYU, where I train PhD students to write papers and to write their PhD thesis. We have an interesting class that's very creative, that combines a lot of hands-on exercises and other things like improvisation taught by actors. And I think it's a great tool to improve, especially the presentation skills of students. So I'd like to start with this slide. It's the slide that I always start my talks with. And it's something I really firmly believe it. If you are a scientist, I believe that you also are a professional writer. No matter how little you like writing, writing is the main vehicle through which you're presenting your science. You're going to write papers, you're going to write review papers, you're going to write research papers. Maybe you can take it a little more broadly. You're a professional communicator, you're also giving talks. And I see the scientists, they're very careful, thorough people, and they are ready to do everything that's good for their research. They're ready to take weeks of classes to learn how to handle a new instrument, to align a spectrometer, to learn a computing language, and so on and so forth. And by the same token, I feel that people should consider writing such an integral part of their profession that they should dedicate a little bit of effort to improving their writing, to improving their oral presentation skills. But at least in the environment where I worked most of my career, I realized that this wasn't really happening, that most people consider writing sort of an afterthought. The most important thing is doing your experiments, is publishing, is doing your science, and writing was a last minute thing that one does when you really have no other chance. I think this is a mistake, because your research is going to get the benefits. It's going to be seen only if you can present it well in a way that's understood by a lot of people. And when I give these talks, especially to young scientists in universities, I think that they have only one thing in mind. Why should they write better? And they come to the seminars, and even my students in the class, they take my class just hoping for one thing, which is they want to communicate well to get published. So the first point here in the list. They think if they write better papers, their chances of being published are higher, and that's the main interest. But I think there is so much more than that we should consider when sort of motivating ourselves to communicate and write well. And to be honest, getting published is probably not going to be affected that much by the way you write your papers. You're sending your papers to a journal for review. It's going to be seen by referees, and especially if you're not publishing in super high-profile journals like Science or Nature, the writing is actually not very important. The referees who are going to see your paper are leading experts in the field. So even if it's not communicated well, they will understand the motivation of your work. They will understand the implication of your work. But there are many, many reasons why we should write well, even when we're writing articles in an obscure, not so high impact factor journal. And the first one is getting cited. I actually did an analysis with a friend who does statistics on paper, and the papers that get cited the most are almost always papers that are very well written, with a very clear abstract, with certain qualities that allow people to understand and then to understand them and then to be motivated to cite them. And obviously citations are probably the number one quantitative parameter for assessing a scientist's productivity, things like the age factor that you're probably familiar with. So I think getting cited, getting your science seen and cited is a very important consequence of writing well. Funding is getting difficult in the US in particular these days. Getting your proposal funded is a process by which you're competing against many proposals that are overseen by program managers and the like. And these are not necessarily technical people in your field. They handle a wide portfolio of research. And so you really have to make the case that your research is important, potentially impactful, beautiful, and you have to make the case with them who are not your direct competitors. They're people who usually have a scientific background, but certainly not in your field. So in order to write a decent proposal, I think you need to write it very well. There are specific techniques for writing proposals that are particularly indicated. Another aspect is the fact that we want to communicate with scientists from other fields. And I see it more and more. I do think that many of the breakthroughs to come in the next years in many fields of science will depend on interdisciplinary collaborations between different fields. I'd like to cite an example that I just thought about because I attended a meeting. It's a project that's called It from Qubit. It's a project that's trying basically to develop a theory for quantum gravity. Very difficult task. And the project brings together specialists in relativity, specialists in quantum physics, specialists in quantum information. The direction this project is taking is sort of looking at everything as bits of information and is trying to integrate this approach to develop a new theory of gravity. And when you see this meeting, you realize that the talks are actually pretty exceptional, because what happens is that you're an expert in general relativity and you have to talk to somebody who does quantum physics, and relativity and quantum mechanics do not merge well. We know that it's a big open question in physics, and so the instruments, the tool, the language are very different. So in this context, people have to speak to each other in a way that's accessible and understandable. So I do think that this breakthrough will only be possible if we talk well and if we write papers that can be accessed across the boundaries of discipline. And then you might have, might be at the beginning of your PhD, and I think, developing communication skills is useful no matter what you're going to do next, even if you might consider going out of academia and doing something else. I think this is probably one of the most important set of skills that you can have for a company to be interested in you. My class at NYU was actually initially possible because somebody from Google decided that it was a useful skill for the students. So there was this professor who had a joint appointment. Other professors were unsure if it was worth investing in this kind of class, but this person said this is likely the most important thing that these guys are going to learn in their PhD. So definitely supporting my course. And finally, have fun. I know that we all chose science because probably we liked the humanities less, or maybe many of us were not particularly happy about writing, and then you find yourself trying to write papers. And if I think of my first paper that I published, it was such a nightmare to get it done. But with just a little thinking and a little training, I think you can transform something that's hard to do and it's something you don't like into something that it's actually a lot of fun, something where you find your writing personality, you show yourself through your writing. And I think it's a very empowering experience, one that has happened to me to the point that I ultimately left science to just do that. And today I just leave writing, editing, and helping other people write. Just a few words about what I was doing before. Essentially, the one in the background is the experiment that I was doing in a sort of modern version of it. The picture that comes from more than a century ago is a horse galloping, and it's too fast for our human eye to see. So back then, two-person Muybridge and Stanford placed the bet on whether the horse at some point in time was actually flying with the four legs not touching the ground. Again, this was impossible to see with the naked eye. So what happened is that they developed basically this concept of stroboscopic photography, where you take a snapshot series, and from the snapshot you can reconstruct and make a movie basically of the movement of the horse. And you see that indeed the horse at some point has the four hooves off the ground. So it's a piece of art, it's a piece of important technology. I think the impact of this image, this photography, was actually felt in the arts more than anywhere else. I don't know if you have in mind some 19th century paintings where the horses are plotted, are drawn with the front legs in front and the back legs in the back. That's unphysical. That's not how horses run. So from the moment that this image was published, horses in art were painted in a different way. Now, the modern version of this, it's not with a stroboscopic camera. That camera is essentially limited by a shutter that you have to open and close. So there is some mechanical movement. So you can go probably to microseconds, but not much more than that. The modern version of this camera is what's plotted here in the bottom right. It's called a pump probe laser setup. What happens here? There are two lasers. One, the red laser starts. It's a start pulse that basically excites a molecule, does something to it, maybe excites some of its electrons. And the second probes some of the properties of the molecule as a function of time. The nice thing with lasers is that you can make laser pulses as short as you want. When I was working, the length was 10th so 1/millionth of a billionth of a second. Today, you can even do attosecond, which is 1,000 times shorter. So essentially, you can follow basically any kind of dynamics that's happening in nature. Certainly, with femtosecond, you can follow the movement of atoms. Now that we have attoseconds, we may follow even the movement of electrons. So this was my field. Of course, I was not measuring horses. We were mostly looking at chemical reactions. And I think, yeah, it was a pretty popular technique back then. I was quite lucky with my publications. Certainly, I did write them well. I give that to me. And I think the most important thing that I did in my life was a study of liquid water, where essentially there is a mechanism in water. It's called a proton transfer, where you have a molecule that gives away a proton from one molecule to the next molecule. So it's called an acid-base reaction. And using that camera, we were able to watch it and monitor its time, and it was 10 times faster than anybody anticipated. And so, people had to go back to the drawing board and develop new models for this particular very ubiquitous kind of chemical reaction. So having done this, and again, I was quite, successful with publications, but I realized there was something that was sort of disturbing me when I was talking with non-scientists, when I was trying to talk about my work with other people. And I actually took a break from science, and I went to work in a very political environment. I was with the European Commission, sort of the governing body of the European Union. And I spent some time there as a scientific consultant to policy makers. And when I started that job, I initially thought, okay, this is an environment where, people don't understand at all what science is, what it is about, why we should do it. It's their fault. We scientists, we know everything, and we just have to educate them. And very quickly, my my approach, my feeling changed when I realized that actually there were a lot of problems with the scientists, with the way they talked to politicians. Some of these politicians some of them had a scientific background, or at least were able to process some scientific information. But when the scientists went into that environment and tried to speak, they were completely unprepared. And I remember one occasion where a nuclear physicist who was going to lobby for nuclear research in Europe. It was a very difficult time just after Fukushima. Nuclear was not very popular. There were calls to close any nuclear power source and to stop nuclear research. So it was pretty important that somebody made the case that we should not stop nuclear investigation. Um, and there were many parts of nuclear physics that are actually not related to nuclear bombs or to dangerous nuclear energy applications. Anyhow, the guy had 5 minutes to talk to the European Parliament. He was a very famous scientist with an H factor of 150 or more. He published hundreds of papers, and he had 5 minutes, and in 5 minutes, he managed to say 4 times quadrupolar moment to an audience of policymakers and lawyers. So there was no way that these people could follow. So after I spent some time in this context, I realized that actually the limitations were more on the side of scientists. We just weren't able to talk to normal people. And I think this has profound repercussions on the way science is funded, on what science is funded. And so we should all as a community think about how we do this and try to improve and try to relate to people who don't know as much as we do. After that experience, I decided, okay, I'm much more interested in this than in real research. And so I took another job. I went back. I did want to go back to science. The environment of politics can be a bit toxic. And so that's when I started working for the American Physical Society, and I became the first deputy editor of Physics magazine, for which I am now the chief editor. And so this is a magazine that I would describe as a magazine that communicates physics to physicists. So our goal is not to communicate to everyone, but we really want every physicist to appreciate all the new developments in all areas of physics. So that's a little bit our mission. And so to do that, we need to find the best papers, and we need to write about them. So some of the things we do in this magazine, we highlight some of the best results published in the Physical Review. I'm sure you've heard about this, LIGO's detection of gravitational waves. The Physical Review still gets some pretty cool stuff. This was the last PRL by Stephen Hawking, weighing on his information paradox on black holes and trying to make progress there. We are also trying to communicate in a creative way. So we do a lot of different articles. One of my favorite types of articles are these cartoons that we do in collaboration with PhD Comics or Jorge Cham. He has a fantastic way to explain some of the most complex things in a very simple way. You just read a cartoon in 2 minutes and you get a very complex problem. This was one he did about a muon G-2 anomaly that could potentially point at some new physics that's not part of the standard model of particle physics. It hasn't reached 5 sigma yet, but it's going there. It seems like it's going there. So it's a very important result. So to do this, we need two things. And so I'm sort of talking about this because I want you to sort of get a feeling for where my suggestions about writing come from. So in my everyday job, I need to find the best science, and then I need to communicate it. And to find the best science, I read hundreds of papers every week. At least I skim quickly through them, and then I focus on the most promising ones. And when I read a paper, I ask myself four big questions. The big motivation: why this research? What is the holy grail we want to discover what dark matter is made of. You want to develop solar cells that are efficient and cheap, for instance. Then a more specific open question. So we get the big picture background, the holy grail. You're not going to solve that big picture question with this paper. There's going to be a more specific open questions. For instance, if you're interested in solar cells, there are a number of solar cells that are very efficient. These days, everybody is studying perovskite solar cells. However, when you put them out in the environment, they degrade very rapidly. So maybe the specific need is to prolong the lifetime of the solar cells. So what is the real specific question? And this is something that it's very important to clarify in a paper. What are you really trying to solve? And there are many papers where this question is not properly articulated. There's just some background, and then at some point, people start talking about what they have done. But if that question is not very clear, it's really hard to assess how your research is positioned within the context of the current research background. And so I think it's very important to phrase that question. And so this is the question that you are going to answer in the paper, or at least you are contributing to answering possibly in the next future. And then the key result, what is really new. And again, in some cases, in many papers that I examine, I really struggle with finding that really new step that the paper is providing that has never been done before. In some cases, I feel the researchers maybe don't want to compare what they did to what's done before, because maybe the increment, maybe the improvement is sort of marginal. And so they think that by just not talking that much about that, people will think that their work is more important. But I think the effect is quite the opposite. People cannot place your work within the context, cannot understand whether it's a step forward and how. So it's really important to focus on what is really new. And finally, the last question that is very important, I would express it as so what? So people have measured something, people have calculated something. What are the implications of the result? This is a section that in some cases is completely absent. But it's a very important one. And I feel that many physicists, when they write the papers, okay, we measure this property of this cold molecules. So what? So what's happening next? What will this experiment enable? How will it help us understand some big fundamental question or develop some applications? This section is quite crucial for people to be able to assess why what you have done is important and impactful. Why is it worth reading? And it's a section that's very often, as I said, completely neglected or written in a way that is not very useful. So once I found the science, once I found papers that have compelling answers to the 4 questions, I added hundreds of scientists. I've edited anyone from a PhD to a Nobel laureate. So I work with them. They send me a draft, and then I help them improve the draft and trying to make it accessible. There are usually people are very appreciative of the process, although I do get some uncommon, I have to say, resistance when I'm trying to edit their work. And these are some of the emails that I'm getting. You're simplifying too much. They will think I'm stupid. So he's equating being simple to being stupid. He really wanted to sound complicated and sophisticated. The second says that if a scientist does not know what a Lyapunov exponent is, he and you should just go back to school. I cannot waste time explaining it, he wrote to me. And the third came from a theorist who just wanted to use equation instead of writing with words. You've massacred my text once again. There is no way to explain why quasi-particles condense. You just have to solve the equations with the inclusions of nonlinearity. So I feel this kind of messages sort of gave me some insights into how these people think and what the challenges are. And I think the main challenge that I see is that we are brought up in an environment where essentially we are talking to a community that is made of our supervisors, colleagues, and competitors. So we are talking to somebody who already knows. We can use the jargon because everybody will know the jargon. We are talking to impress our supervisor. We're talking to be evaluated. We want them to like us, or we're talking to impress our competitors. And as a consequence, we spend a lot of time communicating the how. How did we get the result? How did we do the experiment? What kind of tricks we applied? And not. So the how is, of course, an important part, but you cannot neglect those four questions that I talked about before, the why and the so what in particular. The second message, the one who was saying, if you don't know what Lyapunov coefficients are, just go back to school. This is an example of the challenge called the curse of knowledge. You forget how it was before, how you were before you learn all the things that you spent a lot of time learning in the last years or decades. So you cannot imagine that there are people who don't know. So you're sort of cursed that way. And the third challenge that was common in the three responses is not really thinking about your audience. Again, I think the system of academia forces us in a way to think much more about a very narrow circle of people. But when you're writing in physical review letters, nature or science, you are expected to write something that everybody, every physicist for physical review letters, every scientist for science and nature should be able to get. And so if you don't write that way, you're basically neglecting your audience. You do not know your audience. And so I think you have to do some thinking about what your real audience is. You go to presentations, try to get a sense. If you go to conferences, try to get a sense of who might be sitting there, maybe some young PhD students from other fields who have very little idea about your specific work. So how do we overcome these challenges? And this, I'm going to share some thoughts in the rest of my talk. The first is to have a little empathy, right, with the reader in mind. There is an exercise that we do in our class at NYU that is actually super useful. I would recommend everybody to do it. Basically, we bring in actors, theater actors, and they improvise with the students. And one of the games they play, they put two students together, and they ask one of the students to be a time traveler from the Middle Ages, and the other has to explain their research to that student. Obviously, this is an unrealistic, extreme case, but this is an exercise that allows you to think about the empathy that you have to have for your audience. So you have to choose the words so that the person from the Middle Ages has a sense of what you're talking about without thinking that you're a witch. That's what how the game is defined. Obviously, in the real world, you will talk to time travelers of a different kind. Maybe they're traveling not from the Middle Ages, but from another field. Maybe they're traveling from another research context. So recognizing those time travelers and the places they're traveling from, I think, is a very important skill. The other thing is, and a lot of people think when I give writing classes and seminars, there are people who are just born writer and it's all easy for them, and they just they acquire that skill at birth. That's never true. You learn how to write by practicing. So there are ways to improve your writing, even if you hate it, even if you don't do much of it. And I hope I can share some thoughts here. There are some great books that I will recommend, pretty light books that people can read. And the other recommendation is read as much as you can. All the famous novelists became big because they read everything that happened before them. It should be the same for you. Read a lot of papers outside of your field. Read science journalism, and try to learn from what you read. You read a Nature paper, and it leaves you with a message. It makes you feel energized. It makes you feel that you understood everything. try to reflect on how they built that paper and try to incorporate it in what you're doing. One thing that I want to say to an audience who, like me, is not native, native English speakers, there is zero correlation between how well you speak English and how well you write in English. When I started my job, I had this strange, I guess, stereotype or bias. I thought that when I was working with scientists from Oxford and Cambridge or the MIT, it would be very easy. I could edit them for native speakers. I would just have to fix a few things and it would be very fast and easy. Very quickly, I realized that was absolutely not true. Of course, they had no grammar problems, but the writing was, in many cases, incomprehensible. So I very quickly understood that there is no correlation, and my favorite writers that I work with are actually almost always not native speakers. My favorite one is a Polish scientist. He doesn't know what articles are, the or a. He never uses them. The grammar is really poor, but his drafts come in. They are so beautiful, very logically structured, with poetic descriptions and the like. I just have to correct the grammar. These are things that you can do with ChatGPT or with AI. But writing well has nothing to do with grammar. Writing well is about clear presentation and logical flow, answering those 4 questions. And so I want to encourage you to not feel any barrier because of this. So in the class that I'm teaching, we sort of follow 4 stages of writing. And this, sorry, 3 stages of writing, and that's how we teach it. Of course, writing is a creative process, can go different ways, but the first one that I'd say is very important, and people don't think enough about, is finding your story. And let me explain what I mean with that. I am really convinced that every paper essentially has to tell one single story. I often see cover letters sent to our journals proposing papers for submissions, and they say to the editor, dear editor, you have to publish this paper because of this 10 reasons. First, we achieved a more efficient device than before. Second, this is also fundamentally interesting because this whatever modes have not been seen before. Third, we overcame a materials challenge, and so on and so forth. It's really hard in those cases to assess the quality of the paper. If you send a paper like that to a high impact journal, Nature or Science, if none of the reasons stated for motivating publication is sufficient to publish the paper will not be published. The additive property doesn't have here. It's not that you're making a stronger case if you give them 5, 6, 7 reasons. So give them one story, give them one message that people should retain, a take-home message. This paper is about 2 sentences that summarize the result of the paper. People have a very short attention span. So you really have to make sure that after reading your paper or after hearing your talk, you deliver that one message in a simple, coherent way. Don't sort of blur the message by trying to tell too many stories because people are not going to get it. So these are the kind of stories that, how would you summarize them? Last year, I was in Brazil, I think, when this came out. There was a paper about a thorium nuclear clock, the demonstration that people could excite and measure a transition that could be used to build this clock. So this is the story that sort of how we summarize the story in a couple of sentences in our website. A nuclear clock ticking at the frequency of the transition of the atomic nucleus could be more precise and practical than any existing clock. So that's a little bit of the background and why we're looking for nuclear clocks. Using lasers, we have excited and precisely measured a suitable nuclear transition in thorium-229, taking an essential step towards building such a clock. So nuclear clocks are important. They don't exist yet. Using a laser, we measure a transition that can be used to build them. It's a pretty simple story. So that's the story on which the paper was focused. So one thing that I suggested, to spend a lot of time when you're writing a paper brainstorming about what that one story is, how you would summarize it in 2-3 sentences, a paragraph as short as this one, and use that story when you're communicating to the editor. Say you're submitting a paper to Nature, so dear editor, we're submitting this paper for publication in a journal here, and you present your story. So that way the editors have a very clear feeling of what you have done. So don't try to be too long. Don't try to explain the details of how they measure this transition, what setup they use. Just give them the main story. This is an example from a real cover letter. I always edit them so they cannot be recognized. But this is a cover letter that, you know, was giving 5 points, 5 motivations for publishing a paper. We showed that orbital angular momentum is a degree of freedom that has the potential to be harnessed in non-Hermitian system. We demonstrated chirality can transform an OAM order to a higher order. We showed that 2 groups of exceptional points can be, and so on and so forth. So if you read this, what's your idea about what is the key story presented by this paper? It's completely confusing. Maybe some of these elements can be there, maybe they are sort of important, but try to identify the one that you want to choose, the one that's the real important one, and build your paper around that story. Make the story emerge very clearly from what you're writing. Then, of course, there can be sort of asides and little details that you add to your story. But if there isn't a single story that the paper is centered about, anyone will have a hard time trying to understand the real value of the paper. So think about the story, and for those of you who are young, maybe I always propose some exercises. One exercise would be to write a story, a 1 or 2 sentence summary for some papers that you like from TRL, Science, or Nature. Usually the best places where to look, and try to see what's that story. Is there a story emerging from those papers? The second stage that we work on in our classes is building a story structure. So trying to organize a story, and I think having a story is very important because it really helps you select the elements that you need to tell the story. I'm sure you've been in the lab or you've done your theoretical work and you've done 2,000 different things, but they don't all need to go, no matter how much you care about them, into the paper that you're writing. So if you have a story that's clear, you can select the elements that help you tell that story without adding too much information. And then you can build a story structure that presents these elements. And this is, I would say, the classic structure for a scientific paper. Works in most cases, maybe with the exception of some review papers. But I would say that the 4-point structure is probably the most frequent one. You can apply to almost everything. Starts with the context, the broad why, what's the holy grail, what's the big picture of the field. It goes into the research needs, a more specific why, what is the real open need, the unanswered question that you're trying to solve. And then, of course, the core of the paper would be what you did and found, the how you did the experiment, how you got your result. And finally, as I mentioned, a section that is very often neglected or not done very well, the so what, the implication. So you've obtained some results, what's happening next? And try to use an outline to guide your writing. So you see the logical structure that you are developing as you're writing. You can analyze it, you can read it separately from the paper and make sure that it makes logical sense. See if there are repetitions or detours. Just make sure it's an optimal algorithm that convinces the reader of your conclusions. How much time do I still have? Maybe 15 minutes is okay? Can anybody? Sorry? I'm not sure I understand you. Can you maybe text it?
So can you hear me?
Yes.
Okay, so you still have around 20 minutes.
Okay, that's fine. Great, thank you. So I just wanted to use an abstract as an example of structure of writing. So this is what I call a self-centered abstract. If you read this, this is a physical chemistry paper. We have investigated the lifetime of vibrational transitions in this molecule at some frequencies. We got some results. We estimated that these vibrational modes have this intensity 0.2 plus minus 0.05. The other is 3 plus minus 0.01, and so on. We measure also the dephasing times. You look at this, and unless you work on this molecule, unless you work on vibrational spectroscopy, you really have no idea about why this is important. First of all, you ask yourself, why did they do this? Why did they measure this molecule? Why is it important to know the vibrational transitions? Second, so what? They measure these values. Are they big? Are they small? Are they new? Are they surprising? Is the noise or the accuracy better? So an abstract like this gives you no chance to really understand the value of this paper unless you really work on the specific problem, and so no, you see without anybody telling you. But for anybody who is even slightly outside of the field, I think this is a completely inaccessible abstract. So the why is not there, the so what is not there. One thing I'd like to emphasize, the abstract is using absolute numbers that are very hard to parse, to understand, if you do not know what this number should be. So what does it tell you? It's 2.3 plus minus 0.07. Absolute numbers are something we cannot process easily. So if you're presenting numbers in an abstract, ideally they should be relative, or they should be explained somehow. You should explain why these numbers are noteworthy. Just throwing out some numbers is not going to be very useful in most cases. And I'd like to contrast this with a reader-oriented abstract. I'm a bit unfair here. You know, the first paper was a complicated physical chemistry study. This is a biophysics study. But this is built on that sort of structure that I was talking about. It starts with the problem. Leukemia belongs to a class of complex hard to diagnose diseases that new technologies aim to tackle by measuring the properties of large sets of single cells. So that's the big why, the holy grail. We want to diagnose leukemia. And then the open need. Achieving such a goal depends critically on new approaches to interpret the data. How can information about the disease be derived from massive amounts of single cell information? So it's about large data sets and how to process them. So that's the open need. And here, that's the answer to the open need. Here, it was a single author. He shows that the statistical basically measures the entropy of cell population, the blood cells from a patient, and it shows that they can be this entropy measurement can be attributed with 100% accuracy to whether the individual is sick or not. So essentially, he solved the diagnosis of an important type of leukemia. And then finally, it talks about the so what. The methodology may be applied to other diseases. So we've done leukemia. We can probably do other diseases, and establishes an important link between thermodynamic and biomedical applications. I find this intriguing. You know, the entropy of our bodies increases when we're sick somehow, and there is a quantitative method to infer sickness from entropy. So there is both an applied consequence, other diseases, and a very fundamental one, thermodynamics of our body and its links to biomedical applications. So if you look at this paper, at this abstract, it's very well structured along those 4 questions, and you read it, and even if you know nothing about the field, you get a sense of what they've done, why they did it, and what are the implications of what they did. So this is a very quick example to, and I guess this can be applied to a whole paper. Like, are you answering those 4 questions in a compelling, clear way so that the reader can answer those questions and get a proper assessment of your work? I definitely recommend. I should probably not do it because they're competitors, but Nature as an example of how you build an abstract for their journals. Nature thinks if you had the experience of publishing in Nature, when you send an abstract, you work with their editors and they completely rewrite it. They have very clear guidelines on how to write an abstract, and I do recommend to take a look. And I would say this is not just good for Nature. Even if you're writing for a minor journal, if you write an abstract this way, it's going to be a very compelling abstract that really offers a good structure for presenting your research. So I definitely recommend you take a look and you try to follow something like this. Nature gives a lot of detail of what should go where. We don't have to go through this now, but essentially it's that four-part structure: big why, open needs, what we did, and the implication, with some more specifics that Nature wants to have. So another exercise for the early career scientists there, maybe pick a few articles from Nature, analyze the structure of their abstracts based on their examples. So see if they follow it and see how they're built. Talking about structure, I'd like to talk about paragraphs. So paragraphs, according to the teachers of writing, this book Elements Style, are the unit of composition. So paragraphs are sort of the atoms of your logical structure of the paper. So each paragraph should basically convey one mini story, one unit of thought. And a very effective technique is to have what's called a focal sentence, a sentence that basically summarizes that paragraph. And there are two important options for doing this. There can be other options, but I would say the two most common one are point first paragraphs and point last paragraphs. In a point first paragraph, basically, you tell the reader what the paragraph is about early on. This is the paragraph where LIGO discovered gravitational waves. And the first sentence is the basic features of this event. It's called based on the date of detection, pointed to be being produced by the coalescence of two black holes. So it's telling you the signal is due to two black holes merging. And then it goes on and it gives all the details, the time, the frequency of the signals, the cycles, and so on and so forth, the masses of the black holes. But basically, the first sentence tells you what all of these numbers that are coming up are going to tell you. And so it basically summarizes the paragraph, and it allows you to process a lot of information that's coming at you with the knowledge of what that information already means. So it's a really incredible technique to make your paragraph much easier to digest. And the point last paragraph, that sentence can be at the end. This can work well if you, for instance, you're presenting some data. Let's not go into the details of these complicated papers, but basically it's talking about some experiments and then wraps them up by saying this measurement indicated a quantum state insensitive trapping condition can be attained over a range of wavelengths, relaxing the need for a specific laser wavelength. So that final sentence, okay, now this paragraph in isolation is not very easy to understand, but this final sentence is basically allowing you to condense all the information that you've been thrown before, which might have been overwhelming, and tell you what it means in a quite simple way. So think about that. Think about building point first paragraphs. Think about building point last paragraphs. I think it's a great technique for writing. This is an article on which I wrote a news story, and I think it's the article that made me understand how important it is to use these focal sentences. I read this article, and it's many pages, I think maybe 20 or 30, and I realized I was highlighting that focal sentence. And the focal sentence was almost always at the beginning of the paragraph. And so after I highlighted this, right, and I went back to the paper and I needed to access different sections, I could sort of see the paper from the top, like having a bird's eye view of the paper, and I could see the logical structure of the paper because the focal sentences were guiding me through the paper. What it allowed me was to do what I call nonlinear reading, where you're jumping to non-linearly. It's not that you're following the chronological order in which the paragraphs are presented, but you're jumping from one to the next, and these sentences are anchors that allow you to jump to the point where you want to go. And I can tell you, if you write this way, there are a lot of people, journalists, editors, funding agents, that would have, whose life would be much easier thanks to this focal synthesis. So definitely something that I encourage you to think about. Another exercise, if you want to do something, pick your favorite papers, and I bet that you will find that many paragraphs have focal sentences, and that most of them will probably be in a point first format. So, and finally, just a few more thoughts on effective writing strategy. So you found your story, you developed a structure that tells your story in a logical and compelling way. And then there are some writing strategies that people can work on, can learn about. And I want to share some thoughts. One is economy and lightness. Again, we live and work in an environment where sort of our environment leads us to speak in an academic, stuffy way, trying to be more complicated than is needed. And I think this is a unnecessary, and I think this is a mistake. This is a citation from another teacher of writing. The secret of good writing is to strip every sentence to its cleanest components. So try to make your writing as simple, as concise, as short as possible. A good suggestion is, when your paper is ready, to go through your paper with just one goal: reduce the word count by, I would say, at least 10%, but almost always you can get it down 20%. You are just cutting every word that serves no function, replacing every long word with a short word, taking away every adverb that is not really necessary. So this Zinsner calls this adulterants that weaken the strength of a sentence. So try to be light. And just some comments on this. The first one is really funny to me. I was writing a lot of news stories about researchers trying to understand how birds migrate in the magnetic field of Earth. And I was puzzled because all of these papers were talking about the avian species. And I started thinking, are they talking about birds, or are they talking about something else? Are there birds that are part of the avian species and birds that aren't? Are there some avian species that are not birds? Are penguin birds? I don't know. I got really confused. The truth is, the avian species means bird, and the only reason why they use that 3-word expression as opposed to a 1-word simple expression, everyday noun, is that they want it to sound scientific. This is obviously, just it could work. It's not a problem. But if you consider that people are doing this consistently throughout the paper, always grabbing for that longer, more complicated expressions, when you can just use a simple one, the papers get very easily much complicated in a way that's not necessary. The second aspect related to weakness and lightness, recognize and cut clutter, things that are not really necessary. This is a kind of sentence that I typically encounter in the conclusions of a paper. This work sheds new light on the physics of nuclear fusion in the conclusion of the paper. So basically you're telling people, first, it's new light. So you found out something new on a topic that's the topic the paper is about. So basically this sentence is telling the readers, well, you read something that is new, and that's why we're publishing it on this topic. This is what the sentence really means. So it's not adding anything, can be just cut. If you want to say something new, then maybe you want to explain what that new light is, but just saying it is not adding any information. Adverbs are a category of words that almost always are useless. If you conclusively demonstrated something, you demonstrated it. If you didn't demonstrate it, it's not conclusive. So conclusively is sort of contained in the meaning of the verb. And like, what's the difference between very large and large? I remember one very senior Nature editor who now passed away. She told me that years ago she would do an automatic replace of all the paper she was handling, replacing very with bloody. So that quantity was bloody large. And obviously she go through the paper and delete every instance of bloody because it doesn't really work. And she said no content was lost. So adverbs are in most cases useless. And the last point is active versus passive voicing. Passive voicing, like it's been done as opposed we did it. Passive voicing sometimes is ambiguous. Who did it? Maybe you write, this is being measured, but by whom? By you in this paper, by previous groups. So the active verb is shorter, is more engaging, gives the feeling of an active thing. So I would say this is not, you know, a hard rule, but tend to prefer active to passive voicing. Use short sentences is another very important suggestion. Try to read this paragraph. Techniques for direct phase modulation of laser diodes, typically based on the control of the applied current of voltage and always associated with a very dramatic amplitude and or frequency modulation of the emitted light, have been available for decades while being insufficiently reliable for high bit rate communications and quantum key distributions applications. You can barely breathe when you're reading the sentence. The problem is not the length. It's not that there is a number of words at which you should stop. The problem is that there are so many concepts in here. And it's a simple sentence if you think of it, if you look into the sentence and try to parse it and to understand it. However, it takes a lot of mental effort to do that. You have to put together the different pieces. What if you break it up into smaller sentences? Techniques for modulating the phases of laser diodes have been available for decades. They're typically based on the control of the applied current of voltage. However, because such methods are always associated with a dramatic amplitude or frequency modulation, they're unsuitable for this application. So you see how easily the meaning comes at you, as opposed to this, where you have to work a lot and think a lot before being able to decipher it. So use short sentences. And there are many examples. And again, none of this is intrinsically wrong, but if you consistently go for a clunky phrase that could be substituted with an equivalent shorter one, I think you're making your papers heavier than they should be. So an exercise again, take a draft of the paper of yours and have a step where your only goal is to cut word count and see where that brings you. And in many cases, I can tell you, you can surely do that without losing any information. I want to suggest you to this incredible guide. It's sort of hidden in an appendix of a review of modern physics style guide, but it's really wonderful. It was done by a really nice woman who was an editor with us. And you will see here many examples that are really compelling, and I definitely recommend everybody to read that. This is a book that I recommend. I can share the slides if anybody's interested. Very compelling subtitles, how to write papers that get cited and proposals that get funding. It's a bit old, but I think it really gives you the right high-level principle. I'd like just to add a few thoughts on how we can try to make science a little more fun, a little more personal. We don't have to hide behind academic jargon and language and tone, and we can make it a little bit more personal. And every time I've seen it done, it usually works very well. First of all, use I and we. This is a paper from Einstein. Back then, it was very normal to say habe ich gezeigt, I have shown. People talk in the first person. And today, I think the tendency is rather to write in a passive form. Here, you probably write here it's been shown or something like this. So I feel that we can use personal verbs, and we can also try to make things lighter. This is an example of a title of a paper that's been cited thousands and thousands of times. The initial title was on the breakdown of the Born-Oppenheimer approximation for conical intersections of potential energy surfaces of the same symmetry. The final title, very compelling one, Diabolical Conical Intersections. I guess the thing here, if you are an expert in the field, you know what the first title means, so it doesn't add much to you. You know that's a conical intersection where a Born-Oppenheimer approximation breaks down. if you're not an expert in a field, you sort of get lost looking at this title. Instead, you know, this very catchy title, Diabolical Conical Intersection, I think it works very well. Of course, then you read the abstract, you understand what these intersections are, and so on and so forth. But so this is an example of where we can try to stay away from a very stiff, very long, very complicated wording and just go for something simpler. And I have a couple of more examples. This is from Morrison. I observed that the Hamiltonian philosophy is like avocado. You either like it or you don't. You know, it's pretty funny. Of course, it's Phil Morrison. He can allow himself to write this way, but I think it's a very good way to say, you know, we can use the Hamiltonian philosophy or we can use the alternative. They both work very well. This is another example from Review of Modern Physics. The flux from the star are changing on timescale short compared to journal publication timescales. So they were actually attacking the very journal that they were publishing on. And this is a great one. The difference between the two types of variables can be elucidated by describing two ways of watching fish. In the Eulerian picture, one stays at a point and watches whatever fish happen by. In the Lagrangian picture, one picks out a particular fish and keeps track of where it goes. Again, Phil Morrison. Such a great way to explain in very simple everyday words the difference between the Eulerian and Lagrangian description of the system. I think it's very compelling. It's very light, but also scientifically very effective. So not just having fun, it's really making something that works very well. And I'm about to conclude. I just have a couple more slides. I'd like to talk about figures and visibility. The visual aspects of our papers are very important. We think in terms of images. So figures are a very important part of your papers. One, the image in the background, of course, is the Watson and Crick paper about the helical structure of DNA. One suggestion that I have here, it's a very good approach to build your papers around figures. And once your paper is ready, try to just go through the figures and the caption together. Read the caption, looking at the figures one after the other. Maybe use them to give a mini presentations to yourself. Do they tell a clear story? Do you get the story from doing just that? And I can tell you that many people, including editors, including journalists, including funding agents, read papers this way. They read the title, they read the abstract, and then they go through the figure. So try to allow that kind of way of approaching a paper. And finally, one value that I think is very important. So I'm telling that you're not writing for your competitors or your supervisor, but you're also writing to them. And I think that every paper can have this value of allowing multiple levels of entry. So they should give something to the non-specialist, and they should give something, of course, to the best specialist in the world who works on the same field. So you can design your paper so that as it has different levels in its components. Maybe the introduction and the abstract can be accessed by every researcher. The next paragraphs could be accessed by researchers in related fields. And then the core, of course, the details of the experiments will only be appreciated by researchers in the field. And a very good metaphor of this is a hourglass structure. You start very broad, and then it gets more technical, the core of the paper. So you start with everyone, and then you're talking just to the expert in the middle of the paper. But one thing to remember is to finish broad as well. So that's so what the implication section that is very often not done very well in papers. I think it's a pretty crucial part of your papers, and you have to remember to not stay here at the narrow part of the hourglass. Remember to make that session accessible. And again, I can tell you that these categories of people who are not necessarily the leading experts in your field, who are going to access your paper, that's how they will read the paper. They will start with the introduction, and when they realize, okay, we are missing this part, it's too technical, they will jump to the final part of the paper. So allow them to do this, allow them to access the implications, because it's a key part they need to appreciate so as to appreciate the value of the research. And this is my last slide, where I'd like to recap some values that I think we should have in mind when we write anything, in particular research physics papers. This slide is a handwritten memo from a writer from my own country, Italy, Italo Calvino. He was a very compelling writer. He read a lot of science, by the way, and he was going to give 6 lectures at Harvard for this very prestigious Norton lecture series, where Nobel laureates and musicians and politicians give lectures. And he was going to talk about 6 values that the writer should have, the writers for the next millennium. He was talking about our millennium, that should inspire any writer. And this is something that he was doing for literature, but I think they apply very well to writing about science. The first is lightness. Don't feel that you have to speak in a stuffy academic way. If you can say bird and not the avian species. The second is quickness. The quicker, the better, unless you're losing information. Cut clutter in your writing, and the writing will be more compelling, more efficient. Anything you can remove it. The third is exactitude. I refer that to the logical construction of your paper. Make sure that your papers answer these 4 questions. Make sure that you have a very logical design of the sequence of paragraphs. Think about paragraphs. Think about the logic unit that each paragraph contains. Think about the focal sentences that you can add to paragraphs. Visibility, build compelling figures. Make sure that you allow an access to a paper that's just through the figures. Multiplicity, that hourglass, give that possibility of accessing your paper from multiple perspectives. And then the final value that he talked about, unfortunately, Calvino died on the way to Harvard. I don't think he delivered the lectures, and he didn't write the last one. We just know that the title would be consistency, so I have no idea what he was talking about. But this is my take on it. If you take on this responsibility that as a scientist, you're also a professional writer, and you do that consistently. So every time you have to write something, be it an email, a draft, a full paper, you consider it as part of your profession, and you treat it with the same thoroughness that you apply to other parts of your profession. If you do that consistently, gradually, maybe slowly, but inevitably, your writing will become much better. You will improve. You will realize that your writing will have the clarity of your thinking, that your writing will contain the passion that you put in doing your research. In a few words, you will see that your writing is actually you. You will find your own voice in your writing. It will be an empowering experience. It will be more fun than it used to be, and certainly be more efficient at delivering your messages. And with this, I'd like to finish, and I just want to remind there's 2 resources. This one is open access. You can access it, and this one you might have to buy it from Amazon. It's quite cheap, but I can also send you a PDF if you're interested. So with this, I'd like to conclude, and any question is really welcome.
Okay, let's thank you, Matteo. So do you have questions? So can you hear me? Okay.
I can hear you, yes. Now I can hear very well.
So I think Marco has a question.
Obrigado, Matteo, pela palestra. São muitos exemplos interessantes. Está com um pouquinho de ar?
Sim.
Bom, aí reforça a pergunta, né? Faz 2 vezes. Não, a pergunta que eu queria te fazer é sobre essa era de hoje em dia com inteligência artificial. As pessoas estão usando cada vez mais as ferramentas de inteligência artificial. Por um lado, acho que os textos podem ficar mais fluidos e mais claros, mas, por outro lado, fica tudo igual, talvez, e as pessoas não desenvolvem uma técnica própria, né? Elas acabam se apoiando numa ferramenta. Como você vê esse uso da inteligência artificial hoje em dia?
Bom, o que eu acredito é que a inteligência artificial, ChatGPT, essas coisas, são ferramentas que podem nos ajudar, mas ainda não sabem escrever um artigo. O que aconteceu, por exemplo, no meu curso aqui em Nova York, no dia que começou o ChatGPT, os ensaios dos estudantes eram perfeitos de um ponto de vista gramatical, mas o conteúdo era ruim como antes, tão ruim como antes. Eu não entendia a história que queriam contar, não entendia a pesquisa que estavam fazendo. Então, eu acho que um problema é, especialmente para os estudantes mais jovens, se começam escrevendo com inteligência artificial, não tentam aprender a escrever sem essas ferramentas. Então, nunca vão desenvolver a capacidade de analisar o que a inteligência artificial apresenta e de modificá-lo para escrever melhor. Bom, o segundo é se você usa a inteligência artificial sem ter um conhecimento do que deveria ser um artigo, então não pode melhorar seu artigo. Então, acho que é muito importante começar sem inteligência artificial e usá-la para melhorar alguma coisa que já temos na cabeça, que já funciona, mas não confiar na inteligência artificial para escrever um paper completamente. Isso não vai funcionar. Dito isso, eu acho que é uma ferramenta incrível que pode ser utilizada. Eu pessoalmente não utilizo muito, só utilizo para escrever e-mails que não são muito interessantes. Mas é uma boa ferramenta. Se você tem que corrigir a gramática de um artigo, é perfeito, nenhum problema. Mas se você não tem essas 4 respostas, essas 4 perguntas, a inteligência artificial não vai responder para você. Não vai melhorar um artigo nesse sentido.
Alguém tem uma pergunta aqui?
Eu posso fazer a pergunta?
Não, eu tenho uma pergunta primeiro, rapidinho, Khaled. Assim, o David Mamet tem umas colunas do Office Today dos anos 80, onde ele critica um pouco os próprios editores da APS e da Proof, que cortavam mesmo o jeito de escrever menos muito profissional, não sei o que lá. Eu não lembro os detalhes, não sei se você conhece também esses artigos dele. Assim, você acha que teve uma mudança na maneira que a APS e outras sociedades valorizam o que é escrito? Porque você vai dizer, eu não devo ser também tão impessoal, como mostrou esses exemplos. Isso é uma transformação que vem ocorrendo, assim?
Eu acho que ainda não houve transformação, infelizmente, nem em Nature. Honestamente, eu tenho que ler muitos artigos cada semana, 100, 200 artigos, e muitas vezes eu não faço ideia se é teoria ou experimento. Então, eu acho que a comunidade tem que desenvolver estratégias de escrita muito melhores. Ainda não houve uma transformação. Do ponto de vista de EPS, estou, por exemplo, oferecendo cada vez mais coisas como escrever, como é o nome? Popular Summary, por exemplo. Como uma pequena descrição do trabalho para muito mais clara, muito mais simples. Por exemplo, o que a APS não pode fazer é o que Nietzsche faz muito bem, trabalhar sobre os abstracts. Porque um editor na APS acho que tem que trabalhar em 1000 artigos cada ano. Não tem o tempo de revisar um abstract. Enquanto em Nature, um editor terá entre 4 e 10 artigos cada semana, então tem um tempo de revisar e assim por diante.
Mas eu estava pensando mais na política editorial mesmo, porque eu lembro que o David Mamet contou uma história que ele queria usar um termo do livro do Lewis Carroll e ele foi impedido. Ele tem várias outras histórias, como esse exemplo que você mostrou, de fazer uma pescar ou não, né? Explicar um termo científico. A ideia que ele passa é que isso era meio que uma política, a EPS não permitia isso, esse tipo de coisa.
Eu não conheço o exemplo exato, mas eu acho que hoje em dia é mais fácil, por exemplo, que você fala, usar algo de Lewis Carroll. Bom, talvez seja uma questão de copyright, então não sei, mas eu acho que os editores de hoje são muito mais abertos a essas ideias. Por exemplo, o que você viu, o exemplo de Phil Morrison. Eu acho que hoje aceitariam coisas como essas sem problemas. Então,
Entendi.
está melhorando.
Vai lá, Calete.
Obrigado.
Matteo, muito obrigado pela sua palestra. Eu queria complementar a pergunta do Marco. Você terminou sua palestra com a seguinte frase: Find your own voice. No entanto, nós temos uma ferramenta nova chamada inteligência artificial. A minha pergunta é como conciliar essas duas posturas e se existe um perigo de você acabar se viciando e perdendo a sua própria voz.
É uma pergunta muito boa. A questão é, se você está envolvido no processo da escrita, se você conhece sua forma de escrever, se você já encontrou sua voz, você pode utilizar a inteligência artificial para melhorar. Você pode fazer correções e erros gramaticais, por exemplo. Mas se você não tiver isso, então é um problema muito mais grande, porque é muito fácil você utilizar a inteligência artificial, você o que vai obter é um artigo que soa como muitos artigos que já você conhece. Então, acho que a questão é de utilizar a inteligência artificial de uma forma inteligente. Então, sem substituir completamente o processo da escrita, senão usando a ferramenta para melhorar. Mas é uma boa pergunta. É questão de conhecer o que você sabe escrever e já ter uma ideia. Eu acho que o processo ideal é que a gente aprenda a escrever sem inteligência artificial e depois você pode ter um auxílio da inteligência artificial, mas não começar com isso é muito importante. Por exemplo, eu quando escrevo com inteligência artificial, e como eu falei, eu escrevo só coisas não muito interessantes, né? Uma solicitação para um emprego, um e-mail burocrático, essas coisas eu faço com inteligência artificial. Ajuda muito, mas quando eu o produto, bom, não reconheço que sou eu, poderia ser qualquer pessoa. Sou profissional, sou bem. Ao mesmo tempo, eu sei, como tenho muita experiência escrevendo, eu sei que posso fazer isso, e se quero melhorar o que a inteligência artificial fornece, então posso fazê-lo, porque já tenho muita experiência com isso. Então, a questão é tentar não ser vítimas, não ser preguiçosos e se você usar a inteligência artificial, complementar também com pensar na escrita, pensar na comunicação, pensar na história que você quer contar, desenvolver uma capacidade de analisar os textos, ler muito e usar essa informação para crescer, para melhorar e para poder controlar a inteligência artificial e não ser controlado por isso.
Muito bom, obrigado.
Mas, por exemplo, eu não estabeleceria nenhuma regra sobre o uso da inteligência artificial.
Mas aproveitando o que você falou, Matteo, aparentemente você deve usar a inteligência artificial no último momento, quando você já tem uma estrutura montada, só para lapidar o produto final.
Pode ser, também pode ser. Eu, como eu escrevo normalmente, o que eu faço é começo a escrever muito simples, muito coloquial, muito ruim, né? Eu escrevo um artigo, eu escrevo minhas ideias assim, de uma forma simples. E, então, depois você pode utilizar a inteligência artificial para melhorar esse começo de artigo. E em algum momento você, depois de ter utilizado a inteligência artificial, você entra na escrita outra vez e muda muito. Então, poderia ser ao final do processo, poderia ser o princípio do processo para facilitar, para aumentar a velocidade da escrita, mas o importante é que não seja a única forma de escrever um artigo. Você tem que intervenir em algum momento.
Pergunta? Bem, se não, vamos agradecer o Matteo mais uma vez, então. Bem, obrigado, Matteo, mais uma vez. Desculpa os problemas que a gente teve no começo.
Não, nenhum problema.
E, bem, até a próxima aí. Quem sabe daqui a um tempo você volta para contar mais uma coisa para a gente.
Obrigado para vocês.
Matteo, quando você vier na sua próxima visita ao Rio, a gente marca um encontro aqui e, de repente, você faz... Já estou te contratando para fazer um mini workshop, especialmente para os estudantes. Acho que pode ser uma, duas, assim, claro, se você achar interessante. Eu sei que você ofereceu na PUC um curso assim, não?
Sim, não foi um curso muito longo.
Mas perto de 2, 3 horas, de repente, avisar o pessoal daqui, de repente o pessoal vai assistir lá, se puder, algo
claro,
assim.
Claro, eu gostaria de fazer.
Bacana.
Exatamente. Gostaria também de falar com cada pesquisador e ouvir da sua pesquisa.
Ótimo. Maravilha. Grazie. Tchau.
Grazie, Marco. Obrigado a todos. Até a próxima, então. Bom dia.